Recording.
That's not the one.
Is that
I think.
recording?
Ah, okay. I might stop that.
Good.
Am I good?
Yep.
Your screen sharing. Okay.
I'm just recording through.
I try on the Zoom link. Stop share. It's being recorded. Got it. Okay. Should work. Right. Cool. So,
Screen share.
that screen share should work. Yeah. I think it should work. I could get some. Yeah, I think it's
Yeah, I think it should be, yeah, like it's all like doing something weird. It says all participants could share now.
okay.
It should
We'll
work.
try again.
Oh, Tom, like,
That one?
I don't see it, yeah.
Yeah, just switched off before, so just share that one.
That one, okay. I think we're on.
No.
Everyone's speaking.
Yeah. That one here. Yeah, okay. Cool. Good to go. So they is all about bringing from spreadsheets and data sources to operational outputs, and like to show some case studies in enabling human, animal, and environmental health intelligence. So like to go sort of a little bit with the challenges we have in the transition. And Nick already said in his introductions, we work a lot with open source technology and dashboarding. And I'd like to show you capabilities, but also brought some examples to demonstrate what's possible, and that hopefully inspires you guys a little bit to maybe pick it up in your own work as well. All right. First of all, why bother and why should we look at it, and what has changed over the last year? So when you look at data, so what comes up or what's a concept around it is the 5 V's in relation to what changed. So what definitely changed, I think, is the volume of data. So it's now starting off kilobyte, megabyte, terabyte, petabyte. So it's kind of more and more data that's accessible and we have to deal with. Then velocity of data. I think it's different. So previously, with report writing, you write a report every half year, every year. It's okay to do manual data extraction to process that, but that's often not good enough anymore. A lot of the data is available ongoing, and a lot of people also expect that you have actually near real-time or real-time information available. So it becomes important to connect the data to your outputs. What also changed is the type or variety of data we have available. So it used to be a more traditional data in files or in spreadsheet format databases. So that typically rectangular data, and that goes more from that structured format to unstructured data, and that can be basically in folders on the web, audio files, video, and so on. So we want to extract that information and use it for our purposes. What goes with it is veracity. So also it's a lot about trust these days, establishing trust in the data and trust in the work, the outputs you produce. And specifically over the last years with all fake information, false information, or trying to sort of use data to your purposes and bend it as you wish. So it's, I think it's important to be transparent about what data you're using and what methods you're using, and so that other people can have actually a chance to track it down. So that establishes trust with people in the output, what you put out there. In the end, you want to provide value to people. So also look at your audience and stakeholders. So you want to provide really targeted information they can use then for decision making. And so in our line of work, it's a lot about sort of the traditional way to look at it is from a surveillance point of view. So that's I've got some definitions there, and it's surveillance. The CDC definition is ongoing systematic collection, analysis, and interpretation of health-related data, essential to planning, implementation, and evaluation of public health practice. And then intelligence goes a step further. It's the ability to read and respond effectively to a situation. It's all about how you can gather together data in order to make faster, clearer decisions, and eventually that results in a decision advantage, which enables decision makers to better understand and address the issue. So it's all about looking at your stakeholders and also people in charge who can make decisions to influence them in a way that is based on valid methods. So that's a little bit our target, and the big problem is how you get there. And when we talk to people, so there are always some questions around it, and what's the best way to get there and to provide the insights into my data? Or often it's a concern about the data, it's not in the right format, or the data is incomplete. And so often there's a block there. Okay, am I actually able to produce meaningful insights? Then, yeah, I'm not a programmer or a data scientist. How do I get started, or what tools are available for me? And then how long does it take? Maybe I've got a project, but who knows kind of when it's going to be done. Yeah, so looking at tools for dashboards and for this decision support tools. So it's the suite of out-of-the-box tools we can use, and that's I think a valid entry point, and that has its place. And that's the likes of Tableau, Power BI, Click, so there are a whole range of others. And what we specifically do is, and we believe it's the better approach to go with, and specifically for the research space, it's follow a code-first approach. And so that requires programming. So in our line of work, it's often R to some extent. Also Python, that also always depends on personal preferences as well, and what exactly you want to do. But there are also commercial tools out there. When you look into outputting results, it goes relatively quickly into web technologies, and that's HTML, CSS, JavaScript. So you then often when you get into R and then want to output results, you also got to go a little bit towards those common web technologies. There are, what also is bundled in with R and Shiny is JavaScript framework. So that's for a specific purpose, or times also those more traditional programming languages come in. From an access level, so it's those out-of-the-box tools. So when the business users, analysts, data scientists use them sort of for more the broad brush standardized outputs. Then research area, definitely R and Python. So there's definite drive towards open source technology. However, web technologies and JavaScript programming is more towards programmers. When you use sort of open source versus commercial tools. So what's important to look at and we believe the big advantages are so to start with is reproducibility. So that's what we already said around the trust, so that you have a validated environment, you allow others to reproduce what you've done. And so with open source technology, you can hand over the code, others can exactly inspect what path you followed and what code you've written, and you can give it to others to validate it and to reproduce it. Then also resiliency. So if you have a locked into vendor, vendors come and go, and with open source tools tend to have a greater stability. And big one is participation. So it's a little bit community approach versus single vendor approach. In the space of R, there's, I think we're currently passing, or pretty close to the 20,000 R packages on Crane. So Crane is the biggest R package source out there. So huge variety of libraries you have available. And there are also really, really specialist R packages out there you can use for your purpose. So always pays off to have a look around what's already there, what others put out there. And that's also goes both ways. So there's a lot available, but if you get a chance to develop the piece of our code, let's say, which could be usable to others. So I encourage you to go the extra mile and maybe package it as an R package and maybe publish it on Crane. So it opens it up to others as well, and others can contribute then to the code as well. So that's a good way to share your work, and it also gives a little bit visibility and others see what you're doing as well. And you can then progress and also update it from time to time and share it with others. Accessibility, it's free to access for anybody. There's no license restriction. So we work a lot with R. So what can you do with it? So it's about the general data processing and ETL processes. So that's around extraction, transformation, loading. Can code your models, and the Macerec is doing using that quite extensively. And it's used data analytics science and for data visualization. So was already, when R was originally created, they had already that graphics focus. So base R and a lot of R packages. And now when it comes to sharing your outputs, so when you've written the R script, that's just the first step really, but you want to look into how you want to share it. There are different ways to do that. An approachable way is using Markdown or Quarto. So Quarto is the successor of Markdown. So if you probably want to start a new project now, I would go down the Quarto way. It's pretty similar to Markdown. And so we've tried it. It's in particular better when you output to multiple formats. So let's say to Microsoft Word or to HTML or to PDF. So it's definitely improved compared to Markdown. So that's one way. However, that's so you can output to HTML and put it somewhere for others to access, but you can also set up an email distribution list and get it out there, get your results out there. There are also ways to schedule Markdown and Quarto reports. Then are Shiny for dashboards. And so in the last years, we use Shiny quite extensively because it's really ready-made for dashboarding, and also helps you with data access. So there's a wide range of data connectors available. So that goes from scraping on the web to things like, so you can use pins for, that's quite useful package for data objects you can then share with different outputs you're using, or RDS is the typical R data format, or the binary format, so they can quickly load data and consume it, for example, in a Shiny app. Also, option is, so if you produce data, make that available and want to share it with others, you can use APIs, so application programming interfaces. And what we use in some of the projects is OpenCPU, and Plum is another way to do that in R. When you look at our Shiny ecosystem, so the broad concept is you have a web front end. So when you start off with our Shiny, it does it more or less for you, and you don't have to worry too much about structure. There are a lot of ready-made themes available, and so you can create the user interface, but most of the work happens in the server, where you, for instance, include a model, or you run some code into the processing. And you have also then connected to the server your data connectors, and they can be on the basic level, they can be files within the application, but you can also link to databases or data warehouse, and to other data sources you might, or public APIs, for example. Cool. So like our Shiny, because it's really open and empowers people, so it doesn't lock you into a framework. So you're relatively free about the theming. So you can start off with those ready-made themes, but you can actually design it in a way that you wouldn't know, even we probably wouldn't see that it's a Shiny app. So you can, it's got Bootstrap in the back end, so that's one of the most common frameworks on the web, and so you can modify that as you go. And so as we saw yesterday, it's fairly easy to get started with it. Once you should already have a bit of a background with R, but then it's a relatively small step to progress into our Shiny. And it's free to use. If you already have sort of as part of your project R code available, it's relatively easy to transition. And I'll show you epidemics in a bit. So that's one of the dashboards we've developed. And that was the typical example. So that's about disease modeling and SIR models. So at the time we had a series of models available, but you had to run it manually. You got results in table format, and it was really hard for others to access. And then we built actually a Shiny app on top of it to make it easier for people to explore the data and to extract information they can use. So our Shiny is really specific to challenges, or what you require for when you build a dashboard. And so it's got a concept that's called reactive programming. And so that's split into reactive source, reactive conductor, and reactive endpoint. Sounds abstract, but reactive source is basically a user input. So you might have sliders, you might enable users to upload data, so they can manipulate the inputs. And then reactive conductor is where the processing, the heavy lifting happens on server side. And when you have reactive conductor, so you wrap it into a reactive function, which can be then, and the outputs can be used in multiple ways, because how we often structure dashboards, it's you start off with a chart output, and then you also allow or have an extra tab where you show the data in table format, and you allow maybe users to extract the data, and you can reuse the outputs in multiple formats, and that concept really allows you. And so once an input is updated, it flows through to the outputs you have in the dashboard. What has been a little bit of a trend with the dashboards we built over the last years is that it supports self-service PDF reporting. So what you can do with dashboards, you can include functionality to compile the results you have into a nicely formatted report. And a lot of organizations, they're a little bit stuck in a manual reporting. They got to produce it on a monthly basis, and they move away from it. And so go to that of a dashboard, and then you click a button, and they can extract the information that's there, and they can share it with a wider audience. So they can so they go away from manual reporting. So what it also allows you is come up with really customized user interfaces. So the screenshot you see here, so that's a project we have done for the dairy industry in New Zealand, and that's around facial eczema. And so that's animal disease, which has quite a heavy effect on production. And and you see top right, so that's the severe, it's a bit blurry, but it's the severity of the disease. So they can be either low, medium, or severe. And then you see how it affects production. And there are multiple factors feeding into that, and you can fine-tune the outputs a little bit. So with that example, it was at the start clear, so it needed to run on mobile devices. So we customized the interface so that the key buttons move to the bottom. So like what I think it's on LinkedIn also, they've also got the buttons on the bottom that you can just use the thumb to press it. So and we hide away some of the information that's available on the bigger screen. So what you already sort of use to some of the websites, so you can also do that with Shiny and those interfaces. Right. So I'd like to show you some examples, and the first one I brought along is as a project we worked with WHO and around, so that was to support CLASS. So CLASS is the Global Antimicrobial Resistance and Surveillance System. And so the first task we got into, because they wrote every year a big report. And so as a first step, they had, I don't know, 20, 30, 40 charts in it. And every year they had to create the charts manually. So in the first instance, we started off with R script, which actually produces all the charts. And they could just then, I mean, at the time they were working with another media company who then puts the nicely formatted report together. And so that streamlined the production, so we could feed in always the up-to-date data, and so that helped them with the reporting. And we started with the first version of the dashboard. We are currently working on the update where we include the PDF report generation into the dashboards, a bit what I mentioned earlier on. And so that gives them a chance to slightly move away from that big monolithic report they produce every year, and it goes more towards self-service. I give you a little bit of a live tour, the dashboard, and just bring that up. I need to reload that. Yeah, so with let me switch over. Okay. Do I need to unshare and share it again? See. So just bring it, switch over the Zoom sharing.
Yeah. And then
Yeah. Okay, that's on the second screen. Okay. Yeah. Okay, awesome. Yeah. Turn around. And yes, so in the dashboard we have global, so AMC is antimicrobial consumption data. We have data around antimicrobial resistance and country, territorial, or area profiles. So that's so start off with a little bit. So we always try to start with a bit of a bird's eye view, and then drill into detail as we go. Then let's maybe go into that one. So how we set up the pages, because it's quite some information in there. So we have actually go to charts, so that's like a menu on the page, and we put in anchors on the page. So when you click on it and want to go to a specific area of the dashboard, it scrolls down, so it's still loading here. Yeah, that's coming up now. And so you go to the specific section. And so that's around, yeah, sort of consumption by antimicrobial causes, then by subgroups. So we drill more and more into detail as we go by route of administration. It's about consumption, and so what we also offer is image download, so you can extract the charts, and we also so with the images we add a title and a footer and the date it was extracted. So because you often want to use it for presentations or email a colleague the chart. So it's a quick way to extract the charts here. You can also download the underlying data to each chart. I think there's also, yeah, it's that one. We've got those circular charts in that for MR implementation indicators. So that's around, yeah, one indicator, National Surveillance Plan, National Coordination Center, how many countries participate in that one, or have that established. Test coverage down to global maps of coverage. So lots of data we have if you want to explore that a bit. So we've got it on our website. So I think I've got it on the last slide. So that's openly accessible. Or when you Google WJ class, you should also find it. So click up, and then yeah. So we also have. You can dive into individual countries and get specifics on a country level. So there are quite some countries contributing to the reporting And yeah, so also can go into specifics there. Cool. So yeah, so that was yeah, going yeah, WHO class, and just switch over again. Yeah, so let's run the WHO class. Other example I'd like to show. Just try to get it on the screen as well. Yep. I think we. Yeah. That's, okay. Yeah, cool. Thank you. And right, other example I'd like to show you is about the climate matching tool. And so it addresses the challenge pest risk analysis frequently have, so that they ask if the climate of a pest risk analysis area could be suitable for the establishment of an organism of concern. So it's important for biosecurity and border protection, and we worked with it with AgResearch. So AgResearch is one of the crown research institutes in New Zealand, and was funded by the Minister for Primary Industries. Just switch over to the tool. Okay, so so we start off with the tool. So what you can do. So we've included crop areas. So for example, New Zealand is all about kiwi fruit, so we can select that one. And so we divided up the world in a grid system and into climatic cells. And there are projections for different climates. So that is in the past, but it also goes into, I think we've got 2030 and 2050 projections, so low, medium, and high. And you can see what parts of the world have a similar climate to where, in that case, the kiwi fruit grow areas are. So you can explore that, and you see there's a CMI is the climate matching index, and if you have a dark red color, so that means there's a close match, and the lighter the color, so that's a quite different climate. And so if we zoom out, you see that, and then we can actually project that to a specific climate we choose here, and see and can further investigate sort of what species are maybe prevalent here, and what's the risk then to come into New Zealand. You can also upload locations, and then compare locations, how similar they are to the climate. So it uploaded locations around the Asian region, and you can then you get further outputs how similar those locations are to compared to the kiwi fruit area. So, and that is which have a CMI greater than 0.7. So I get further output around that one. So you can run a couple of other comparisons. So we included weather station data, and you can then select a specific weather station and compare it with others. You can then also choose the climates you want to compare. And last visualization is around. Let me choose an example. So let's go. Let's see them maybe. Then let's go to Europe and France. I think that's, yep. Okay, so we've got a climate group 1 compared with climate group 2, and then we run the comparison, and we package that into table, and you then see which locations have also close match, and yeah, where the climate is relatively different. So you can be added, yeah, also sort to it, so you can then look at a particular location and see which where the climate is relatively close. So we've got Auckland here, and then Cannes, so it's a 0.73 match. Good, and you can also download the results you're having. All right, then spec. Made it. And yeah, third example I'd like to show you, because I know that was already, just go to that one. Okay. Yeah. Third example I'd like to show you is epidemics, and some of you might already have come across it. So now that vet school uses it part of teaching of disease models, and so that's a collaboration project we've done with University of Hong Kong, so with Professor Pfeiffer and Guillaume Vanille from, so used to be at RBC. I think he works for a private company, and so that's around disease modeling, and it's not that much predicting course of disease. It's more a teaching tool so that you can explore what parameters feed into how a disease develops over time. And so, yep, so give a quick tour of it. And we included actually this little feature, so let's take a tour. And then, so it starts off with selecting a model type. So we currently have 8 or 9 different SIR models in it, and we have also disease-specific models. So that's currently African swine fever, avian influenza, and COVID model in there. And So like that. And then with the model setup, so we wanted to allow people to share the parameters they're using. And for instance, when you have a teaching scenario and you want to share it with the students, and so they have a certain starting point. And then so you can download the parameter. So it's a pretty extensive parameter set. But you can then share it with, so you download this in a JSON format, and then you can share it with others. They can re-upload it into the app. So because we didn't want to have a login or anything, because it should be openly available. And we also kind of have predefined parameter sets there, other contribute. I'm not too sure if that's already, there's already something there, but it's still to come. Then we have certain infection states to consider. So typically, susceptible, infectious, symptomatic, and recovered is available, but you can add like infectious, asymptomatic, for example, as well, and other parameters. Define the host population, so population size, if it's a closed or an open population, and run transmission dynamics and control strategies. So that's currently we've got vaccination and culling. Yeah. And define simulation parameters. So for the stochastic models, it's number of simulations you run for, and you select length of simulation as well. So you can then get certain outputs. So how the disease evolves over time. And we also have a supply data table format, and I think that has been added last year. That's a parameter compare function, so you can compare, for example, control strategies. And I see the time. Yeah, we can still show that. So first, what I got to do to get some meaningful outputs is I add a control strategy. So, and that is vaccination. And so as a default, we've got 0.5 of the populations vaccinated. And so I got a parameter compare. Proportion of vaccinated, and then I see how the disease evolves when I have just 20% vaccinated and compared to, let's say, 80%. Okay. So I see then, so that's the comparison one, comparison two, and the dark line is the preset, so with 50% vaccinated. And I see, so that's susceptible, then get the typical curve of infectious systematic, and it sort of peaks when I've got low vaccination rates, and it flattens when so I've got high vaccination rates, so what you would expect. So there are lots of other parameters you can play with, but that's roughly how it works. Also got network model in it and spatial model. So feel free to have a look and use the tool as well, if that's in your line of work. What would be good is if you use it as part of teaching, we have a resources page. And so we we'd like to ask people to if they have something to share, and you have practical examples how you use the app to so reach out and share it with us, and we put it on the website so that others can use it. There, I think there is one from Kim Vanderwaal. So she shared some of her teaching notes there. So that was and so there's some regular hold webinars as well where we share how to use the tool. It's yeah, it grew quite. So it's already goes back 6 or 7 years, and we constantly adding things to it. So yeah, feel free to. So it's all publicly available and free to use. Cool. So switching back to that one. Yeah, so if you want to already made a bit of a start with our Shiny, we have GitHub page available where we extract functions we typically use in our dashboard and make them available. So you can go there and grab the code, so how when you want to use user authentication or how to go with custom theming. So there are some examples there, and you can to use it. Yeah, otherwise it was from my end. I think we are almost there time-wise. So hopefully I can take a couple of questions as well or comments. Thank you. Questions? Yeah.
This stuff is great, but it takes a long time to make, and skilled people need to be paid. So, like, how do you decide how to monetize certain things and not other things, and then approach like working with academia or industry or the government, where like they have very different ways of rewarding certain things or not? And also, like, what's your bigger kind of like thoughts on how all that shakes out?
I mean, we definitely have some passion projects, and we don't make any money on those ones. Academics, I think, was, and we knew it, and that's okay. So we quite like to do some projects, but I mean, we are also commercial entity and with staff, and so we got to make sure we get paid as well. It's a bit so we typically scope out the project and look at what it takes to get to a certain point, and how we do it is we typically have a bit of a design phase up front, and I think Nick and Amy and Alex, they done the same with you guys. So we have graphic designers on board, so they can help us with the user interface. And so we first sketch it all out, and you can do it really easy. Don't know with PowerPoint, maybe draw it up, but you should have, before you really get into coding, a clear picture what you'd want to do with that. And so we use Adobe XD, so that's a graphics design program, and we sketch out the interface, and we basically talk with our clients what functionality should be in there, what should be the user experience, who's accessing it, what's in it, what sort of that first minimum viable product, or to put it out there, and maybe map out a little bit the roadmap for it as well. And then we see how much work it's going to be to develop it. With our design is an iterative process, so we typically go to 3 or 4 reviews, and then also once we move into development, we go through a minimum of 3 or 4 test phases. So where we develop it, we test it, make changes, test it again, till we get sort of to a production ready version. So we look at the project, scope it up, and estimate the effort, and hope, fingers crossed, it's we're gonna get there. Yeah. So depends a little bit, and so have some of the projects and the ones, so AS Explorer is a great example. So pressure, so it's always nice to continue working with it and to see the product evolving. It keeps it fresh as well. You can keep engaging with your stakeholder, what's new in it, and like to see software not as a one-off task. So it's typically something you need to, like a car, you need to fill it up and so kind of clean it from time to time. And so same with the dashboard. So it's a little bit of an ongoing work. That give you a little bit direction.
Yeah, I'm just like wondering if you see yourself as like a really flexible consultant that can work with someone versus like having to buy a Tableau license for like all this.
Yeah, now I mean we don't work with Tableau or something, so we focus on the code first, particular our Shiny dashboards, and otherwise we go all the way from. I mean we teach our Shiny, so we run annual master classes, and our Nick in the back, so he's is running most of it, and so we do that. We do coaching, and that's also a little bit hand holding during a project, and so we do then weekly catch ups or so on. And so it's from the kind of almost like training all the way through to completely taking over projects. And with AS Explorer, it was a bit of a hybrid, so there was already code available. So that was quite involved. Now it's from Alex in particular. And so it's more collaborative working on it. So we probably with the dashboard coding, we take on most of the bits. Yeah, so it's most projects are quite collaborative. Or we take on, yeah. Cool.
Wondering, like, what are the capabilities of a lot of these programs? And, like, is it a focus to make these HTML documents like friendly to people with disabilities? Are there lots of capabilities to do that, like blindness or something?
Yeah. So with accessibility, so we do basic stuff like check against color blindness, and we do as a standard contrast. So that's the typical one when you have light text on slightly darker background. So sometimes it's just not well readable, and then you have a bit problem with reading. So that's, and it's good practice to do that. There are a couple of more things. I mean, you can go quite far that it's accessible as a screen reader or something. And then you need to sort of, for every element you put, so you add an alt text to it. The problem is a little bit with, because dashboards are very interactive, so there are filters and there are charts actually. That's really tricky to make it available for screen readers. What the route we go there, or people go, so you provide information in an alternative in a text-based format, so that screen reader can go through, or you provide sort of an extra part of your website so that is screen reader friendly, and you do a bit of a write-up what you see in a chart or things like that. It's a tricky thing with dashboards. It's a bit easier when you have more flat websites, because then you can scan through it and it's more accessible. But yeah, so we try to go to a certain point, but then yeah, you can just often go so far. Yeah.
Ken, we don't have any questions online. No, nothing in the chat.
Yeah, and some of the dashboards, so they already go a long way, like with Nick mentioned with AS Explorer, it goes already, I think, 5 or 6 years back. And so it's quite an ongoing project, and a lot of work goes into it. So and same with the WHO class dashboard. So it's definitely and the epidemics, it's one of our bigger projects. Also we always go with customized interface, and so I mean that's a little bit the high-end stuff, but I think when you progress you can get relatively far with those standard themes, and that's totally valid to start off with. But when we get involved, it's often that it has, like with the class report, it goes out to a relatively wide audience. It's to look really polished, and then we try to make that happen. But that's another step on top. Yeah. Cool.
Well, thanks again, everyone.
Awesome. Yeah. No, thanks for having us.